let's talk about the current weather forecast for, we'll just say West Virginia for today. There's some interesting things going on. I mean, we just had a cold front go through. Some of the coldest air we have seen in years coming in right now. So with that, I thought I'd just start out. We got to know what's going on first before you can actually make a good forecast. So what is happening? If I look at the satellite, I wanted to point western part of Illinois. That is snow. So that area out there you're seeing is snow cover. Now, look off of Lake Michigan, and you'll notice that the western side of the lake is clear, and the eastern side of the lake is cloudy. We've talked about, matter of fact, you had a question about how does an air parcel change as it's moving across, and what you had was Lake Superior. Well, Lake Michigan provides the same example. Air is cold, dry on the western side of the lake. It hits the lake. What happens? It begins to warm from below, so it becomes unstable. Moisture begins to advect into it off the lake. And what you wind up with is a deck of clouds on the eastern side of the lake and some snow showers there. Over West Virginia, we've talked about air being forced to rise up over mountains. Well, guess what? Look at where the line of clouds kind of ends on the eastern side, right on just over the edge of the highest ridges in West Virginia and down along the Appalachian there. So again, the air is being pushed up. We have west winds pushing the air up, and you wind up with clouds. A lot of the winter time, we can get west winds that help to lift over the mountains. They're cold, they may be fairly dry, but if there's any moisture that's picked up from the Great Lakes or whatever, you wind up with more clouds in West Virginia, especially the eastern part of West Virginia, where you're getting into the mountain ranges at all. So that's why you wind up with a lot of clouds there during the wintertime. And as is typical, you're winding up with it today. We have winds today that are coming out of the northwest in West Virginia. You can see, and there's a front that's coming through. They're going to become more established out of the northwest. And this is cold air. Look at the temperatures up here. -2, -9, -9. Yes, it's going to begin to modify as it's coming out of its source region. But it's still quite cold, even for this time of year. So one of the things I would be looking at if I'm forecasting in West Virginia today is I know I have some pretty strong cold air advection coming in. I have winds not fully off the lake, but at least hitting the mountain chain in such a way that I'm going to wonder about whether it's going to make some clouds out of it. And so with all of that, I wanted to just show you, just looking at another aspect of this. We talk about Arctic air, we talk about continental polar air, and we talk about El Nino. El Nino for the U.S. means we have a southern jet stream right here coming into actually well south of almost southern part of California, has another little low right with it here. We have a northern jet stream up here coming across Vancouver, north of there, into the parts of northwestern. However, they do kind of merge every once in a while, and that is what happened here over the eastern U.S. right now. So that is why we got the storms we had the other day, rain, but we had a southern stream track coming together with a northern stream, and they're going to happen all winter long. Whether they develop out in the Midwest more and move that way, or whether they develop here in the southeast and move up the East Coast, it'll fluctuate throughout the winter. But you're having two jet streams. So that's why Southern California will get some strong rain, probably at times with the southern jet stream. Up into Canada, we'll get strong precipitation and strong lows with the northern jet stream. And one of the things I wanted to look at here, we look for source regions for the cold air. If I am looking for where our cold air is coming from right now on this jet, it's coming out of northwestern Canada. This sometimes develops way up the Siberia area. When that happens, you get a strong northerly jet, even more impressive than this one, coming down into your area. If that were to happen, then I would be more really looking at the Arctic air. However, while it's cold, it could be far worse. So, and that is something also typical of El Nino. We get a lot of air coming out of Canada, but at the same token, we don't necessarily get it all coming off the Arctic or off the North Pole area. So you get a lot of cold, but not extreme cold. So all this plays into what's going to happen. Notice that if you think about it, we don't have a lot of observations over the ocean. We have satellite over the ocean, which is a wonderful tool, but we don't have a lot of ships out that are reporting data. Now over land, we do have a lot of upper air stations. We have, again, satellite, all of that helping to understand what the actual weather pattern is. That's why a lot of times things that are over the Pacific Ocean, before they hit land, we may not have quite as good of an understanding of them as you might get otherwise. So, and with that, what happens is we wind up developing some forecasts. We'll try to take a look at just a high-risk forecast right now. This is a numerical model. This model is for later today. Notice some showers coming in. Well, snow flurries, actually, these are called. Probably be with the color here. And we also can see off of that lake effect. We saw it here. We see it here. That west wind is developing a lake effect that's on the east side of the lake. So if you lived in Buffalo, New York, we'd be getting lake effect snow up there. It would depend. Again, you'll notice there's streaks of it. Here's one, here's another one. That's the interesting thing about lake effect. It hits areas more intensely than other areas. You can drive into a whiteout condition and then drive out of it into nothing, where there's been hardly any snow. And that is the type of weather pattern we're in right now for the next couple of days. Yes, it's going to modify. And I want to look at that. But I'm going to look at it a little different way than you may be used to seeing it. What I'm showing you here is a spaghetti diagram. We have, in this chart, 500 millibars. We have that very strong jet coming across into California, then east, kind of rippling back up to the north, isn't it? Where it was down across our area or even south of our area with time. Now it's moved back to the north. So you wind up with more of little warmer conditions, just low up over Hudson Bay, and one heck of a mixed up area over Alaska, right? This is a 5-day forecast, and you can see there's all kind of variability in it. Now, all these is one set of numerical models with one set of initial conditions that has been changed statistically to make it hopefully representative of what the atmosphere is somewhere in that set. And then we know that we can't solve the equations perfectly, so we take another set and run it with some of the same initial conditions but slightly altered numeric physics, so we can try to account for everything that's going to happen. So somewhere, hopefully, in this envelope of solutions is the exact solution. That's why when you hear a forecast, you're getting what we hope is the correct one because we're interpreting it, but it may be within the bounds of what you're seeing here, somewhere in that. Instead of the jet being further north, maybe it's a little further south. Maybe the storm track might have shifted as well slightly. So we're getting better and better, but We're not perfect. And the closer we are to the short term, yes, we're getting pretty doggone good in that. So I wanted to just give you a taste of what is going on today. And this is all related to how you forecast the weather. All the different aspects that we use. We use several different numerical models. We look at analysis first. We might start with satellite. We might start with the surface map. We're trying to understand what's going on now and how that's going to change and evolve into the future. So, hope you got a little bit from this. And please don't hesitate to ask if you have any questions.